A few months ago, one of my sponsors sent me this nice sample of barbituric acid. I didn't know what to do with it at first, but after doing some research, I learned that it could be used to make violuric acid, a chemical notorious for its extremely colorful compounds. So in today's video, I'll be making a small amount of this acid to see how colorful its salts truly are. As a brief warning, some of the reagents I'll be working with are potentially dangerous. Sodium nitrite is fairly toxic, hydrochloric acid is corrosive, and mixing the two can produce hazardous nitrogen oxide fumes, so it is fairly important to wear protective equipment and work in a well-ventilated area. Alright, with that now out of the way, let's get into the actual synthesis. For this reaction, we'll need the following reagents: barbituric acid, sodium nitrite, and hydrochloric acid. I'll be employing several other chemicals later on to make the colorful salts, but these are the only ones that we actually need to make the violuric acid. To start, 0.59 grams of sodium nitrite is measured out and dissolved into 1 milliliter of water. We don't need this solution at the moment, so it's temporarily placed on the side. Next, 15 milliliters of water is added to a 50 milliliter round bottom flask, and the barbituric acid is weighed out. In this case, we only need 1 gram. This is combined with the water in the round bottom flask, and stirring is commenced. Barbituric acid isn't very soluble in cold water though, so we'll need to crank up the heat to get everything into solution. Slowly but surely, the barbituric acid dissolves, and we end up with this nice clear solution. And now, to start the main reaction, we drip in the sodium nitrite. This causes an immediate change in color, with the mixture shifting from pale yellow to a deep red, and finally to a rich purple, reminiscent of potassium permanganate. These vivid colors signify the formation of sodium violurate, which fortunately means our reaction was a success. But of course, we're not done yet. I didn't do all this just to see another purple liquid after all. So to our sodium violurate solution, we dropwise add a few milliliters of concentrate hydrochloric acid. As you can see, this causes the solution to slowly fade back to a more yellowish color. The hydrochloric acid reacts with the sodium violurate to produce sodium chloride and violuric acid, which are both far less colorful than the original sodium violurate. You might also notice a small amount of nitrogen dioxide bubbling out of solution. This is just the result of unreacted sodium nitrite being destroyed by the acid, and it shouldn't really affect anything. Anyways, once the solution is no longer red, it's time to crush out the violuric acid. Like its parent barbituric acid, violuric acid isn't very soluble in water, especially when the water is cold, so dropping the flask into an ice bath should force most of our product to precipitate. And sure enough, that's exactly what happens. Upon disturbing the solution, an off-white crystalline solid begins to crash out, which is our final violuric acid. The solution is kept on ice until everything is cooled down, and then the solids are gravity filtered off and washed with a bit of ice-cold water. At this point, we could choose to dry the crystals, but since I'll be using most of my sample directly, there's not much point in doing so. So, let's move on to the fun part. In these test tubes, I've prepared a variety of aqueous solutions for the violuric acid to react with. From left to right, we have pyridine, sodium hydroxide, ammonia, hydrazine, tert-butyl alcohol, and hydroxylamine. The ammonia, hydrazine, and hydroxylamine solutions were all made by freebasing their respective salts with sodium hydroxide, and while this did work, I kinda messed up and added a bit too much hydroxide. You'll see why this is an issue in a second. Upon adding the violuric acid, we can see a variety of beautiful colors emerge. The hydroxylamine and pyridine both produce rich purple solutions, but the precipitates couldn't be more different. While the hydroxylammonium violurate is purple like its parent solution, the pyridinium violurate is an extraordinarily vibrant shade of orange. Quite the contrast. The tert-butanol solution is really the only disappointment out of the bunch. I was hoping to get a colorful violurate ester, and I even tried catalyzing the reaction with sulfuric acid, but to no avail. Anyways, now on to the funny business happening in the other 3 test tubes. The sodium violurate is an eye-catching shade of red, and on the surface, it seems like the ammonium and hydrazinium violurates are as well. But that is where I caught my mistake. You see, I had researched some of the violurate salts beforehand, and I knew the ammonium salt should have been a lovely shade of purple, so evidently I added a bit too much sodium hydroxide to my solutions. Fortunately, this minor blunder was relatively easy to fix, and all I had to do was drip in a bit of hydrochloric acid. The more reactive chloride ions bind to the sodium, freeing up the violurate ions to react how we want. And sure enough, the extra acid does the trick, and we finally get to appreciate the true colors of hydrazine and ammonia. Now, to showcase the wonderful array of colors violuric acid can produce, I've assembled 3 of my favorite samples. I saved some of the original sodium violurate from the initial reaction, which crystallized out of solution and left this gorgeous, hot pink precipitate. The pyridinium violurate also crashed out as it formed, so I drained off the blue solution to isolate the uniquely orange solids. And finally, I chose the hydrazinium violurate since I just love the deep royal blue solution it gives, and the purple precipitate is also fairly attractive. Honestly, it still blows my mind that all these colors came from violuric acid, which has little to no color by itself. To show you just how potent these violurates are as colorants, I've dissolved a few crystals of violuric acid into this beaker full of water, and now I'll sprinkle in a bit of sodium hydroxide. Almost immediately, you can see the vibrant colors of sodium violurate in solution. I'm going to add a tiny bit more hydroxide and give it a swirl just to drive the point home. As you can see, this stuff is incredibly potent. A few milligrams was all it took to turn almost half a liter of water strawberry red. It almost looks good enough to drink. I wonder why. Can't put my finger on it. Ah well, there you have it. Making one of the most colorful chemicals on planet Earth. Thank you all very much for watching. I'm super grateful that I got to share this little experiment, and I'm especially grateful to all the sponsors whose contributions made this project possible. I have 3 in particular that I want to mention, starting off with Backyard Science 2000, who supplied me with both the barbituric acid and the sodium nitrite. He runs an eBay store that sells a ton of unique chemicals, so if you're having trouble finding a certain reagent, be sure to hit him up. Similarly, if you ever need bulk quantities of certain chemicals like hydrochloric or nitric acid, be sure to check out Alchemy Labs. He sent me the hydrochloric acid I used in this video, as well as several liters of nitric acid, which I'll be using in later projects. His reagents come with an easy-to-remove seal and thorough labeling, which even includes the lot and product number, so you can verify the chemical's quality. I'll put a link to his website in the video description for anyone interested. And finally, some of the glassware in this video was sent to me by Cell Supplies. They have a ton of high-quality glassware and equipment available for prices that rival both Amazon and eBay, and their inventory is almost always expanding. Seriously, if you want reliable new glassware for a solid price, visit their website using the link in the video description. Additionally, a huge thanks goes out to all my supporters on Patreon. If you'd like to join my community of channel supporters and get your name at the end of my videos, or simply give a one-time donation, check out the links below. Alright, that's all for now. I have several exciting videos that I'm working on, including a dopamine synthesis, a special on ultra-stinky isocyanides, and a DIY electric foundry build, so make sure you like and subscribe to stay in the loop. Until next time, LabCoatz out.